Hello my dear students, this is Meena, chemistry teacher. I welcome you all to the Vidhyalakshmi CBSE school. Today I am going to take organic, one of the most important chapter. Hereafter we are going to upload other chapters videos also. So let's start the topic. Chapter aldehyde, ketone, carboxylic acid. Chapter itself we can divide into aldehyde ketone as one part and carboxylic acid as another part. And this chapter is very important in CBSE point of view as well as NEET and JEE point of view. So today we will mainly focus on CBSE point of view. So first we will start aldehyde ketones chapter, aldehyde and ketone. Aldehyde and ketone. What is aldehyde? R C double bond OH. So this C double bond O group is known as carbonyl group. This group is known as carbonyl group. Carbonyl group, one side hydrogen and another side alkyl group. This functional group is aldehyde. If I am taking carbonyl group and both side you have alkyl group, this compound is known as ketone. So from carbonyl group, one side hydrogen, other side alkyl group is aldehyde, and from carbonyl group, both side alkyl group is ketone. Here in case of aldehyde, except formaldehyde. In case of formaldehyde, both side of carbonyl group you have hydrogen, and this compound is known as formaldehyde. This compound is known as formaldehyde. So aldehyde and ketones both contain carbonyl functional group, and one side of carbonyl group alkyl group, other side hydrogen is aldehyde, both side alkyl group is ketone. So in this chapter, from which portion questions are coming? So we will divide whole chapter into three parts. So from aldehyde ketones, you are going to get question from nomenclature part. Very important. Compulsory questions will be there, 1 or 2. And second part from where you are going to get question is preparation method. And third part is chemical properties and physical properties. So we can divide whole chapter into three parts. One is nomenclature part, second one is preparation part, and third one is chemical and physical properties. So all this part questions are coming. And most important, under this we will be going through many named reactions. Named reactions are like heart of organic chemistry. Direct questions you will get from the named reaction. So first we are going to learn about nomenclature part. In nomenclature, see, IUPAC nomenclature, we have to follow system. In IUPAC naming, we have to follow system. It contains three parts. One is center, which is known as root, ode, or ode root, you can say, ode root. Here you have prefix. Left side you will be having prefix, and right side you will be having suffix. So any IUPAC name of any organic compound contain three parts. One is prefix part, what will write starting. Then another one is ode root, which will write in center, and last part is suffix. So prefix also two types. One is first we will write secondary prefix, then we will be writing primary prefix. And suffix also we have two parts. One is primary suffix, another one is secondary suffix. So let's learn what is the primary suffix. Primary prefix and secondary prefix. Secondary prefix indicate substituents, or you can say branch or branches, or you can say side chains. So secondary prefix indicates substituents, branches and side chain. Primary prefix only will use for cyclic compound. For other compounds we will be avoiding primary prefix. Then what does this odd root indicate? Odd root indicates number of carbon in main chain or parent chain. We can say in main chain and parent chain. And comes to the primary suffix. Primary suffix indicates type of carbon-carbon bond. For example, if carbon-carbon bond in main chain or parent chain is single bond, we'll use primary suffix as a N. If it is a double bond, we'll use primary suffix as in. If it is a triple bond, we'll use primary suffix as a ine. So, primary suffix indicates type of carbon-carbon bond in parent chain or main chain. In parent chain or we can say main chain. And if all carbon-carbon bond are single bond, then we'll use the primary suffix as N. If it is a double bond, we'll use in. What does this secondary prefix indicates? Secondary prefix indicates functional group. So since we are dealing the chapter aldehyde and ketone, the secondary prefix for aldehyde is Al and for ketone is ONE, O-N-E-1. So any IUPAC name contain three parts: secondary prefix and primary prefix, prefix part, odd root center part, and suffix is last part. In secondary prefix we are going to write first what does it indicate: substituents, branch or side chains which is not included in main chain. For example, methyl, nitro, methoxy, ethoxy, etc. What is the primary prefix? Primary prefix only will use for cyclic compound in the form of cyclo. Odd root indicate number of carbon in main chain or parent chain. Already we know if it is a one carbon will use meth, 2 carbon will use eth, 3 carbon will use prop, 4 carbon will use but, 5 carbon will use pent, 6 carbon will use hex, 7 carbon will use hept, 8 carbon will use oct, 9 carbon will use non. Already from 10th itself we are learning this odd root. Now primary suffix and secondary suffix will be writing in last. Primary suffix indicates type of carbon-carbon bond which already was explained, and secondary suffix indicates functional group. So here in aldehyde we will use the secondary suffix as Al, and for ketone we will use ONE. So let's go to the question session. So for example, I am writing CH3, CH, Cl, CH2, C double. Simple questions are coming in CBSE. So this question also one of the previous year question. So now how do we do the numbering? So first part is select the longest carbon-carbon chain. So longest carbon-carbon chain including functional group is this one for me. Now after that you have to numbering. How you will number? Start numbering from that side from where functional group should get lowest number, lowest possible number. So we should try to give lowest number to the functional group. Then we have to try to give lowest number to the double bond, triple bond. Then we have to try to give lowest number to the substituents. So giving lowest number priority is what? Functional group. Then we have to give for double bond and triple bond. Then we have to give for substituents. So we have to try to give the lowest number according to this priority. So if a compound contains functional group should get the lowest number. If functional group is not there, then check for double bond, triple bond, and double bond, triple bond should get the lowest possible number. Then if double bond, triple bond also not there, or they got same number from either side, then we'll try to give to lowest number to substitutes. So let's do numbering here. So here this carbon is 1, this is my functional group which is a aldehyde, and this is a second, third and fourth. Now first we have to select longest carbon-carbon chain. After selecting longest carbon-carbon chain, we have to give the numbering. Now numbering part also over. After that you have to follow this 3 parts to write the name. First, what we'll write? First, we'll write the substituents or branch. What is the substituents over here? This is the side chain or substituents which name is chloro. Which name is chloro. And the chloro is present in which position? That also you have to indicate. So, 3 chloro. Now, is it cyclic compound? No. It is not a cyclic compound, it is a open chain compound. Then that means primary prefix we are not going to use. Next we have to go for odd root. Odd root for 4 carbon is but. Odd root for 4 carbon is but. 3-chloro-but. Now what kind of carbon-carbon bond are there? All carbon-carbon bond I can see in my compound is single bond. If it is a single bond, what I am going to use? Primary suffix N. And which position you have functional group? First position you have functional group 1Al. Now, one more point, what IUPAC says, while writing the primary suffix and secondary suffix, if A, E, I, O, U vowels, if these vowels come together, avoid the first vowel, So, I can avoid this first vowel and I can write name as a 3-chloro-butane. One position you are writing, not writing your wish children, you can write also, you can avoid also, but other than one position compulsory you have to mention. If you don't mention the position, if it is other than one, then they will deduct your mark. Or IUPAC mark is like if you write 100% correct, full mark. If you don't write, like they will not give you half mark or something. It will be wrong itself. So this is the name of this compound. Now we'll try for ketone. CH3, C double bond O, CH3. So what is the name of this ketone? Same procedure will follow. Now our longest carbon-carbon chain will be this one. Now numbering, either here I am starting or here anyhow my functional group ketone is getting second number from either side. So 1, 2, 3. Now there is any substituents? No substituents, no branches. All carbons comes under parent chain or main chain. So 3 carbon, what is the odd root? Prop. And all carbon-carbon bond are single bond, so I am writing N. And 2 position you have functional group. What is the functional group suffix for ketone? For ketone we will be using suffix as a ONE. So propane 2-on. Here also same thing children. So E and O coming one after another. So we can avoid the first vowel and we can write it as a propane 2-on. Now, if same compound contain aldehyde also and ketone also, what we will do? So, if the compound contain both aldehyde as well as ketone, we can write as this. We have to use the priority order. If same compound contain more than one functional group, if same compound contain more than one functional group, we can say multifunctional compound, then we have to use the priority. For example, priority of carboxylic acid is more than aldehyde than ketone. So in a same compound, if aldehyde and ketone is also there, if both compound are there, aldehyde as well as ketone is present, then what we will do? The more priority functional group will be chosen as a major functional group or principal functional group. Then other functional group will automatically become as a side chain or substituents. So if you are having more than one functional group, the highest priority functional group will behave as a functional group or will write in the terms of secondary prefix, so secondary suffix, and other functional group will automatically become as a substituent or branch or side chain. So we'll practice such questions. Even such questions they are giving in exam. For example, CH3, CH, Br, CH, C double bond O. Now, here if I see my compound, here I can see this is a aldehyde functional group and this is a ketone functional group. So I have two functional group, aldehyde as well as ketone. As we know, priority of aldehyde is more than ketone. Then what will happen? Aldehyde will become principal functional group. Then ketone will become substituents. Now we cannot use the prefix name and suffix name same. What is the suffix name for ketone? Suffix name for ketone is ONE. Suffix for ketone is ONE. Now when it becomes substituent, we have to use prefix name. Then remember, prefix name for ketone is oxo or keto. You can use oxo or keto. Remember, each functional group have their own prefix name and suffix name. When they will become prefix? When we have to write prefix? If they become substituents. When they will become substituents? In a compound, if other functional group are there which are having higher priority. So lower priority functional group will become substituents. That time we have to use the prefix name. We should not use suffix name, or we cannot use the suffix name. So here, let's do numbering. So this is a 1. Why I am starting from here? Because my functional group should get the lowest possible number. Then 2, then 3, 4, 5, 6. So in my main chain or parent chain, I have 6 carbon. Then where I have substituents, now this third position keto group becomes substituents. Then fifth position I have substituent it as a, this substituent name is bromo. This is bromo and this is what? Oxo. Now when you are having more than one substituents, the substituents name should be written alphabetically. We have to write the name of substance alphabetically. Now bromo and oxo, which will come first? B will come first. So how I will write? 5 bromo, 3 oxo. Now my first part is finished, that is substituents part. Next, what is the odd root for 6 carbon? Hex, and carbon-carbon bond are single bond N. And first position you have aldehyde functional group. So 5 bromo, 3 oxo, hex N, 1 all. Or simply here E I avoided before itself because E and A both are coming together, so I avoided. So this is the IUPAC name for this compound. Now we'll do some of the naming. C double bond OH. What is this compound? Benzene ring, and benzene ring you have aldehyde. So this compound name is benzaldehyde. Actually benzaldehyde is common name. This common name becomes so famous that IUPAC also accepted this name. But if you want to write the 100% IUPAC name, we'll write in the form of benzene carbaldehyde. Why we are using carbaldehyde? Now I am going to teach you that. Okay, before that we'll practice some of the questions of ketones also. Now if I am writing say benzene ring and C double bond O, CH2, CH3. Now you are having this side benzene ring, this side open chain, or you can say cyclic system and open chain system. When you are having such choice, means you are having cyclic ring also, you are having open chain also. So in such case, which will be parent chain, which will be substituents? Remember, we will be selecting out of cyclic compound and out of open chain, the parent chain or main chain will be one, which is having the functional group. And same priority will be follow like previously I wrote, like if you have to choose, same order will be follow. So if you have the two system, one is open chain system, another one is cyclic system, which you will be giving more priority. The one which is having functional group will be checking. The one which is having functional group will be chosen as a main chain. Now both are not having functional group. Then check for double bond, triple bond. Anyone means either cyclic or open chain which is having double bond, triple bond will select as a main chain. And double bond, triple bond also not there. Then we'll check the substituents. Same order we have to follow. So understand, if we are having two kind of system, one is open chain system, another one is cyclic system. Open chain system and cyclic system, the one which is having functional group will be select as a parent chain or main chain. Other one will automatically become side chain or substituents. So here if I see this is our open chain system, this is our open chain system, and this is our cyclic system. This is cyclic system and this is open chain system. Now if I see here, open chain is having functional group. Which is this functional group? Ketone functional group. Keto functional group. So what I will do, open chain will be my parent chain. Why? On the base, on what basis I have select as a parent chain? Because it is having functional group. That means obviously this part will become substituents. Then you have to remember, I think you must know, when benzene become as a substituents, what will be the name of this? It is a phenyl. It is a phenyl. Like if methane, if CH4, if you remove one hydrogen and if you write as a substituents, you will write methyl. You will write methyl. You will write methyl. Same manner from benzene ring C6H6 I am writing. If I remove the one hydrogen and in that position I am attaching with something else. That means if it becomes substituent C6H5 and here I am joining something else. So that time we will call it as a phenyl. So remember, like how if methane becomes substituents, we will write methyl. In the same manner, if benzene ring becomes substituents, we will write the phenyl. So that means this benzene ring is a substituents for us. So its name should be phenyl. And which position now? You just number it. 1, 2, 3. So first position you have phenyl. 1 phenyl, 1 phenyl. Now how many carbon? 3 carbon, prop. All are single bond. And first position you have functional group 1 on. So 1 phenyl propane 1 on is a name for this compound. See in your exam, 1 mark questions for board exam, vice versa also they can ask you. Vice versa, son, by giving name they can ask you structure also. By giving name they can ask you structure. Okay, so we will be seeing this. For example, question, write IUPAC name of, this is 2012 question, CBSE 2012, CBSE 2012 All India, CBSE 2012 All India question, name of CH3, CH double bond, CH, CH2, C double bond OH. Okay, this is the one question, first question. And second question they are asking, draw structure of 1 phenyl, 1 phenyl but 1 bond. So this questions already came in CBSE. So they can ask you two type of questions. So one is by giving the structure they will ask you to write the name. Another one is by giving name they can ask you to write the structure. So you should be thorough with both kind of question. So first we'll do the naming. Naming is very easy actually. So here if I select, this will be my main chain direct, no confusion over here. So when I select main chain, numbering will be starting from here, nearby my functional group 1, 2, 3, 4, 5. Now 5 carbon means what is the root word? Root word will be pent. And what kind of carbon-carbon bond? See, here you have double bond, at least one double bond also there. Then you have to write primary suffix as a in by mentioning its position. So which position you have? Now you may get confused. 3 and 4 position, both position double bond. Always the first number will be giving while numbering. So pent 3 in and first position we have functional group 1 all. Or simply first number you can avoid. Other than first we cannot avoid. But first number you are writing, not writing it is the same. You can write pent 3 in all. Pent 3 in all also you can write. Now come to the second part. This is by giving structure, by giving Name, you have to write the structure. So whenever this part is very, very important, children, for conversion question also they will give you name. First your work should be convert that name into structure. Not only for here like nomenclature part or writing structure, other questions also this part will be, this concept will be very useful, like in conversion question. So whenever they are giving name and you have to write the structure, always first catch root word, not prefix part. Not prefix part. Prefix part, forget. Last moment only you will write. Always while writing the structure, you focus in this second part. The second part means what? Word root first. First focus on word root. Then go to the suffix part. Then only come to the prefix part. Very, very important. Now, but means how many carbon. First try to write the skeletal structure. It will be very easy for you. First try to write the skeletal structure. But means how many carbon. Already we know but means how many carbon. 4 carbon. Clear? Now, what is this? But 1 on means what? On means what? Ketone functional group. So, which position they are giving you? First position. So, 1. Finish. It will be very, very easy. First, cast the word root. Then go to the suffix. Then only come to the prefix. Now, 1-phenyl. This is what? Prefix part. So, 1-phenyl means this is my 1 number because here I have started this functional group. Now, this position you will be having phenyl group. Phenyl group means what? Benzene ring. Very, very important. Now, remaining valency of carbon you can satisfy with hydrogen. Now, it will be CH2, CH2, CH3. That's it. So, always whenever name is given and you have to write the structure, always you catch from word root. Word root, suffix, then only come to the prefix. So, we will practice some more question here. Same draw structure, same pattern. This is a. Now, second B was, this already came in board exam, para-nitro benzaldehyde. So, these questions are already previous year board question. Para-nitro benzaldehyde. So, what I told, first you focus on center part, benzaldehyde. So, already you know this benzaldehyde means what ma? Benzene ring and CHO group. Benzene ring and CHO group. So, we have to draw benzene ring and here we are having CHO group. So, this center part towards end you have to focus first. So, benzene ring and CHO. On benzene ring if you are having CHO, we call it as a benzaldehyde. Para-nitro. Now, already you know what is ortho-para position. For example, I have any group in benzene ring. With respect to that group, immediate position is ortho. Next position is meta. Next is para. Om Prakash. Remember as a Om Prakash. So, immediate to that group, any position in benzene ring you have any group, immediate to that group is immediate. Next position of that group is ortho. After that position, next position is meta. Then opposite position is para. So, here what they have given you? Para. That means opposite position. Which group is present? Para-nitro means nitro group is present in opposite position. Nitro group present in opposite position. So, this is the para-nitro benzaldehyde. Para-nitro benzaldehyde. Okay. So, like this kind of questions will come practice mode. Next we will be going some exception is there. Normally for CHO, normal suffix is Al. That time carbon is count. We have count carbon and we are using suffix as Al. But you have one suffix which is known as special suffix. Special suffix for CHO is carbaldehyde. Special suffix for CHO is carbaldehyde. Now, and when we are using the special suffix, the carbon of CHO is not count. It is not count. Now, when carbon is not count, we will use the suffix as carbaldehyde. When carbon is count, we will use the suffix as a Al. But it is not our wish. So, here if you may ask you, here I will not count carbon, so I will use carbaldehyde. No, you cannot use. When we will use, that is special, see name itself is saying nice special suffix. So, when we have to use carbaldehyde, when we should not count the carbon, you should know. So there is the two condition when you will use the carbaldehyde suffix. Everywhere we cannot use, only there is the two situation where we have to use the special suffix. First situation is when CHO is directly attached to cyclic, or you can say ring system. Very important. When CHO directly attached to ring system, that time we will not count carbon of CHO and will not use the Al, we will use carbaldehyde. That time what we will do, other naming of ring you can do with normal rule, like name of the ring system. So here name of ring first we will write, and plus we will write carbaldehyde, plus we will write carbaldehyde. Name of ring plus carbaldehyde. For example, I am having CHO and here I am having methyl. Okay. Name of ring means in ring if you are having substituents, same manner whatever prefix, all the things you can follow in same manner for naming of ring. But only thing is, if the CHO is directly attached to carbon, will not count the carbon of CHO and will use the special suffix as a carbaldehyde, will not use Al. That's it. So here what I will do, this number to which functional group attached I will give 1, and this has a 2, this has a 3, 4, 5. So what is the substituents in ring system? So name of ring means all the rules you have to follow. All the rules you have to follow and write the name of ring. Now 3 position I have methyl. So what I will write? 3 methyl. This is what? Secondary prefix. Now primary prefix also we have to use over here. Why? Because our compound is cyclic compound. So what I will use? Cyclo. And how many carbon you have? 5 carbon. So cyclopentane. 3 methyl cyclopentane. Name of the ring finished. And now since CHO group is directly attached to ring system, so what we will use? Carbaldehyde. We will use carbaldehyde. So very easy ma. When CHO group directly attached to ring system, the name of the ring by following the normal rules plus you will write the carbaldehyde. So name of this compound will be 3-methyl cyclopentane carbaldehyde. 3-methyl cyclopentane carbaldehyde. So this is the one case where we will use the special suffix or special name of carbaldehyde. The second where we will use. Now second case is when CHO when more than 2 CHO present in a symmetrical system, or you can say when the functional group are a part of symmetrical system. Now what is a symmetrical system? We will see over here. Now try to understand here. Suppose if I am having CH2 CHO CH2 CHO. So what I will write for this? I will write over here, I will do 1, 2, 3, 4, 5. So what will be the name of this compound? Pentane. 5 carbon means pent. All carbon bond are single bond. And first position and fifth position you have functional group. What is that functional group? Al. See, if you are having only one functional group Al, but 2 functional group are present in which position? First position and fifth position. So we are writing 1,4, 1,5 diol. If 3 are present, triol. But here what will happen, children? If it is more than 2, see here, that's why I took, when there are only 2, we can include this functional group carbon in main chain, so no problem. If there are only 2 functional group, we can apply this 2 functional group carbon in our main chain, so there is no problem. But if I am having more than 2, now if I am having more than 2, so if I am having more than 2, what will happen? See here, CH2, CHO, CH, and this is very important, very important. If you can refer the previous year question bank, always repeating CH, CH2. It is repeating in NEET and JEE also, it is repeating in board also. If I am having like this, what will happen? See, if I count this and this like previous one, then this is a partiality to this functional group. All are same. right? All are Papam Bichara na. So we cannot do partiality to this functional group. So to give the identical treatment to all the functional group, all three are equal. If I am taking this and this in main chain, that means I cannot miss this functional group in my main chain or parent chain. That is the partiality for this functional group. So to give the identical treatment to all functional group, what we will do is, we will not count the carbon of this functional group. We will not count the carbon of functional group. So what we will do is, we will take only this system name, and all these three functional group will write in the form of carbaldehyde. See, listen very carefully and note down the notes. This same rule will be applicable for carboxylic acid also. Same thing will be applicable for carboxylic acid. In aldehyde we are using carbaldehyde. In carboxylic acid we will use carboxylic acid. But other than that, everything will be same, like symmetrical system, and when COH attached to benzene ring or any ring system, the name of the ring plus carboxylic acid. So all rules will be same. So please learn here carefully, and directly you can apply for carboxylic acid also in a similar manner. So here what I will do, I have to write the name of this system, and this three I will write in the form of carbaldehyde, which is a special suffix. So what is the name of this? 1, 2, 3. What is the name of this? 3 carbon means propane. 3 carbon means propane. Now, what is the position of our functional group? Position of our functional group is 1, 2, 3. Now, if you have only one functional group, carbaldehyde, but you have 3 functional group, means what you will write? Tricarbaldehyde. If you are having 4, tetracarbaldehyde, and so on. So please remember very carefully, normal suffix of aldehyde is Al, but special suffix of aldehyde is carbaldehyde. Everywhere we cannot use the special suffix. Where we will use the special suffix? Only in 2 cases. One is when we are having the symmetrical system, when there is more than 2 functional group, we cannot do partiality to 1 or 2 functional group. So in order to give the identical treatment to all the functional group, what we are going to do? We are going to treat them as a special, and we will write the special suffix. And when the carbon, CH, that functional group carbon is directly attached to ring system, name of the ring plus carbaldehyde. So just write the, pause video and write this answer. What will be the answer for this? CHO, CH, CHO. So now what will be the name of this compound? Please pause the video and write the answer. So always you try nomenclature or whatever may be question, pause the video and write the answer and check whether your answer is correct or not. So here also same, this will be my principal chain. Then what will be the 1, 2, 3, 4. 4 carbon means what I will write? Butane. 4 carbon means I will write butane. And first position, second, third, fourth position, what functional group we have? We have aldehyde, and which is named as a carbaldehyde. So 4 means what we will write? Tetracarbaldehyde. Tetracarbaldehyde. Very important. Very important. All this. Okay. This is also very important. And you have this part also very important. So you have to try to take the concept and apply to different questions. Okay. Now, see, same thing you can apply for carboxylic acid also. What I said for carboxylic acid, COH, since same chapter only, here itself I will cover over here this also. Here normal suffix is oic acid. For carboxylic acid, normal suffix is oic acid. And in this, if you are using the oic acid, carbon is count. Carbon is count. Carbon of this COH is count. But I will use special suffix as carboxylic acid, and that time I will not count the carbon. So carbon is not count, very important, and we will use the special suffix, that is what carboxylic acid. Special suffix is carboxylic acid. And same thing, two cases we will use the special suffix when COH is a part of a cyclic ring system, and another one is COH is part of symmetrical system, or you can say more than 2 COH present. Then in order to give the identical treatment, we will be name them as a carboxylic acid, same manner. Okay, same thing you can practice. So do this as a, you try on your own question. Write IUPAC name of following. So this you try to do on your own. One is now many children will get confused on benzene and cyclohexane. Please remember, benzene means here you will be having double bond, triple bond. This is a cyclohexane. So different. Cyclohexane is different from benzene. Please try to do that. And here having this one, and this I am having same CH2, COOH, CH, and CH2, CH. Please try in the same manner, I'll give you one hint. Now this is the, what is the name of the ring? Cyclohexane. And here this COH is a part of ring system. So what I have to write? Cyclohexane carboxylic acid. Cyclohexane carboxylic acid. So same manner you try for others also. Okay. Now IUPAC system is this much. You try to do more and more questions, and the best way to prepare for exam is first listen to the class and revise the notes, then check the previous year questions. First you try to do the previous year questions. That will give you the one path whether you are going in correct direction or not. So always after learning you have to do application. Where you will do application? You will try to solve the previous year questions and revise concept, solve the previous year questions, practice the equation. That will make you master in organic. And remember, the children which will be rank holder or toppers, those children will be topper or rank holder who are master in organic. Why? Because organic is like, if you learn, you will like lot. It is like it will give you pleasure when you are doing. But if you don't learn the basics, then you will feel it as a very tough. So please learn the basics, practice and solve the questions. And from organic part you will get the more weightage, 33 marks, physical 24 marks, and inorganic 16 marks. So please try to practice the equations, try to write the name, and if you are not proper in naming, see, if you don't know name itself, how you will know other things? So if you want to know something about someone else, first what you will ask? What is your name? Same thing in organic also. If you are not knowing naming, then how you will know the other things of that chemistry, organic? So first you have to be very perfect in naming and go for the reactions. So these are all are what? IUPAC naming. See, some common name are there. See, IUPAC naming like if you burn based on your time of birth, the stars, everything. Like Pandit will keep you the name, like this letter, the name should be start with this letter. Same thing like IUPAC name, systematic. And common name is like nickname. Common name is like a nickname. So everyone has the parents might keep nickname on their naughtiness or something. Normally they will keep. So there is no rule for common naming. So like that, but common name also important. So there is no rule for common name. Common name mostly will be writing based on source or their uses, but there is no particular fixed rule for the common naming. So just remember some important common name. One is like HC double bond OH, which is known as formaldehyde, and second one is CH3C double bond OH, which is known as acetaldehyde, and you have like that. So formaldehyde, acetaldehyde is the most commonly used common name. This is what? Benzaldehyde. Already I have given you before. So these three are common name, but even though they are common name, frequently the CBSE will use, or in your textbooks or question paper or anywhere you will see these names: formaldehyde, acetaldehyde, benzaldehyde. Same manner for ketone. The first member of ketone is CH3C double bond or CH3, which is known as acetone. Common name is acetone, which is present in nail polish remover also. Okay, this is the acetone. Now, if I am writing benzene ring, C double bond O this. See this part alone now for ketone will use as a phenol. We'll use term PHENONE. So phenol. For example, if I am writing CH3 over here, it becomes acetophenone. It is known as acetophenone. So instead of that CH3, even if I write one more benzene ring, it will become benzophenone. So acetophenone, benzophenone, acetone. These ketones are benzophenone. This common name also you will be looking in your paper, textbook or some other sources frequently. So they will use acetone. How they will ask the question? Acetone react with methyl magnesium bromide. What is the product? So if you don't know what is acetone itself, how you will write the answer? So please be thorough with some of the important common name. Every compound's common name we cannot know, but some of the common name which is frequently asked in exam, frequently visible in paper, that common name we should be thorough. So these are the common name: formaldehyde, acetaldehyde, benzaldehyde, acetone, acetophenone and benzophenone. Okay. So with this nomenclature part is over. Next we will move to the preparation of aldehyde and ketone. See, very important. In preparation also we have three parts. Very lengthy chapter this is. One is preparation of both common method aldehyde and ketones. Second part exclusively aldehyde and third part exclusively ketone. So preparation also again three parts we have. First we will be looking the common method of preparation of aldehyde and ketone. Okay, preparation of aldehyde and ketone means common method aldehyde and ketones. Preparation of aldehydes and ketones. First method is oxidation of alcohol. Oxidation of alcohol. Now, very important. Now, I am taking primary alcohol RCH2OH, CH2OH. I will write according to my convenience CH, H and OH. According to my convenience, we can write according to our convenience. Primary, this is what? Primary alcohol. Primary alcohol. If I use the mild oxidizing agent, already in alcohol phenol chapter we have studied what is mild oxidizing agent, what is strong oxidizing agent. If you want, just I can give you a little hint. Here mild oxidizing agent are like PCC, pyridinium chlorochromate, and PDC, pyridinium dichromate, and you have CrO3 plus CH2Cl2, dichloromethane plus chromium trioxide. So these are what? Mild oxidizing agent. Now what are strong oxidizing agent? So if I want to say about strong oxidizing agent, mild or you can say weak or mild. If I take about strong oxidizing agent, which are KMnO4, potassium permanganate, in any medium you can take, acidic medium, basic medium or neutral medium. Potassium permanganate in any medium, all the three medium, acidic, neutral and basic medium act as a strong oxidizing agent. Then I will be taking potassium dichromate K2Cr2O7 in acidic medium, K2Cr2O7 in acidic medium act as a strong oxidizing agent. And third one is Jones reagent. What is Jones reagent is like, if I am taking here see, CrO3 plus CH2Cl2 is weak or mild oxidizing agent. But if I take CrO3, same CrO3 with H2SO4 sulfuric acid, then it will act as a strong oxidizing agent. So CrO3 plus H2SO4, if I take this combination reagent is known as Jones reagent, and this is a strong oxidizing agent. So very important, when I am taking CrO3, both are common. But here, if I am taking CH2Cl2, it is a mild oxidizing agent. But if I am taking H2SO4, it is a strong oxidizing agent. One more you can take over here. If I am writing CrO3 aqueous means water. It also acts as a strong oxidizing agent. See, knowing the function of reagent in organic is very, very important. Now, if you see PCC, PDC, what is the PCC? Pyridinium chlorochromate, PDC, pyridinium dichromate, and CrO3 plus CS2Cl2, these all are mild oxidizing agent. But if I am taking KMnO4, K2Cr2O7 and Jones reagent or aqueous chromium trioxide, these are strong oxidizing agent. Now come to the hard part. This see, primary alcohol. In alcohol chapter, we have, if we are using strong oxidizing agent, primary alcohol will directly convert to acid, carboxylic acid. But if we want aldehyde, if we want our reaction to stop at aldehyde level, we have to use mild oxidizing agent. So any one of these mild oxidizing agent you can use. I am using PCC. Now see how the oxidation will take place. Now the hydrogen from OH and hydrogen from the carbon to which OH attached. Please try to understand the equation. The hydrogen of OH, that hydrogen, and the carbon hydrogen. Which carbon hydrogen? Not other carbon. The carbon to which OH attached, this hydrogen. So this hydrogen and this hydrogen I will be removing in the form of H2. Now what will happen? If you are breaking bond, you have to make bond also. So carbon valency is what? 4. Now what will happen? Carbon and carbon, hydrogen is there. This carbon, this bond is with carbon, not with hydrogen. So children already knows, I think, right? This always, this compound is like this. The carbon is making bond with this OH. Here carbon, OH and H. This H, like this actually. Now, when we broke this bond, here will be the double bond, C double bond O. So this is what? Aldehyde. So very important, primary alcohol, oxidation of primary alcohol. Which reagent? Very important. Mild oxidizing agent, I am writing over here. Any of the mild oxidizing agent if you use, what you will get? Aldehyde. And MCQs form question can come also. Which of the following reagent can convert ethanol, which is a primary alcohol, to acetaldehyde? So remember, any one of this reagent, can convert primary alcohol to aldehyde. Now questions, one more question is to come. Which of the following is the best reagent to convert primary alcohol to aldehyde? So this question already repeated in competitive exam also and last year board also. See, which reagent is the best reagent to convert primary alcohol to aldehyde is PCC. PCC, you can convert with PDC also, you can convert with other reagent also. But among these three, PCC is the best reagent to convert, note down, PCC is a best reagent to convert primary alcohol to primary alcohol to aldehyde. Primary alcohol to aldehyde, important. Now let's check the secondary alcohol. So remember, primary alcohol on oxidation with mild oxidizing agent, that is very important. With mild oxidizing agent, what we are getting? We are getting aldehyde. Now come to the secondary alcohol. So here I am writing RCH. So according to before itself we will write conveniently CH, OH and here H, R. Secondary alcohol, no? Here R. So this is what? R, CH, OH, R, secondary alcohol. Now in secondary alcohol I can use any of the reagent. Any of the reagent means either mild oxidizing agent or I can use strong oxidizing agent also. See here, for primary alcohol, strong oxidizing agent means carboxylic acid, weak means aldehyde. But in case of secondary alcohol, whether you are using strong or weak, any one you can use in order to convert secondary alcohol to ketone. See how we will convert? Same manner, ma? The carbon to which OH attached, that hydrogen, and the OH hydrogen, this. So the hydrogen which is attached to oxygen, that hydrogen we are going to remove, and the hydrogen attached to carbon. Which carbon? That carbon which is attached to OH group. So these two we are removing in the form of H2. So I am removing in the form of H2. Then what I will write? When I am breaking the bond, same manner. See here R. Now this hydrogen, this bond we have broke. So here double bond O. What we got? Ketone. Remember, so oxidation of alcohol. Which alcohol? Primary alcohol we can get aldehyde. Secondary alcohol we can get ketone. Very important. So this is the first method. What is first method? Oxidation of alcohol. Which alcohol? Primary alcohol with the mild oxidizing agent gives aldehyde. Secondary alcohol with strong or mild, any oxidizing agent will give you ketone. Okay. Next we will go for second method. Next we will be going for second method, that is same similar to oxidation, only second method also dehydrogenation of alcohol. Second method is dehydrogenation of alcohol. Dehydrogenation of alcohol. See here, name itself is saying what is the meaning of D? What is the meaning of D? D means removal. What is the meaning of hydrogenation? Hydrogen. Removal of hydrogen. Removal of hydrogen. Okay. By removing the hydrogen from alcohol, we will get the aldehydes and ketones. Just before also we have done same thing, right? We have removed the hydrogen. But here reagent will be different. Previously what reagent we took? Oxidizing agent, mild as well as strong. But here in case of dehydrogenation, what we will do now? Reagent will be copper or silver followed by heating. And very many times this same reaction is in alcohol chapter also. How questions come from here? When vapors of primary alcohol passes over heated copper, what is the product? You can look at the previous year question bank, same question would be there. When vapors of secondary alcohol passed over heated copper, what is the product? Same question. So that is this reaction. So why they are calling vapors? Let's learn. Now if I am taking primary alcohol R, same manner like previously CH2OH, and I am copper heated. What is the temperature? 573 Kelvin. Why they are using in questions as a vapors of primary alcohol, vapors of secondary alcohol? Why? Because at this temperature, look at the temperature, very high temperature, the alcohol will evaporate. It will become vapors. So because of that, they are using the sentence vapors of primary alcohol passed through the heated copper. So because of that, understand. So same thing, primary alcohol, when we are heating with copper at very high temperature of 573 Kelvin, what will go? Dehydrogenation will occur. Dehydrogenation means same manner. What I am going to do? I am going to remove the hydrogen. From where I am going to remove the hydrogen? Same manner. One hydrogen from carbon, one hydrogen from the oxygen, remove in the form of H2. Then you write the product. What is the product over here? Aldehyde. RCHO. RCHO. Same thing, you can write C double bond OH also. So C double bond O and H. Or you can write directly RCHO. What is remain? RCHO. Same thing, primary alcohol to aldehyde. Now, same like previous concept only, children. Now if I am taking secondary alcohol, let us take CH3, CHOH, CH3. I am passing over the copper, and what is the temperature I am keeping? 573 Kelvin. So I am passing the vapors of secondary alcohol. Copper heating 573 Kelvin. I am passing the vapors of secondary alcohol through the heated copper. See, listen to the word and note down also how the questions are coming. Okay, when vapors of, after chapter finish, we will practice all the previous year question also. First we will deal with the theory, then we will practice. When vapors of secondary alcohol pass through the heated copper, what will happen? Dehydrogenation will happen. Dehydrogenation means what? Removal of hydrogen. This hydrogen and this hydrogen will remove in the form of H2. Then what will be the product? CH3CO. I can write C double bond O, CH3. What is this product? Ketone. This product is ketone. Very important. Dehydrogenation of alcohol. Primary alcohol undergo dehydrogenation gives aldehyde. Secondary alcohol undergo dehydrogenation gives ketone. And what is the reason that you have to see? Now from this, one more type of question they will ask you. How they will ask you question over here is, see, just I am giving you one, already I informed you. What they will give you question? When vapors of primary, secondary, anything they can use, primary alcohol passed over heated copper, what is the product? what is product. So MCQs form also they can give you 1 carboxylic acid, B aldehyde, C ketone. Now this board exam also they are asking MCQs, assess and reason and everything. D you have something I can say ester. Okay. So what is the answer over here? Primary alcohol means it will give you like this they can ask you. So one more how they can ask you children. One more way they can give you the left side reactant and they can give you the arrow mark and reagent. And they will ask you to write the product. So that way also they can ask you. One way is this way. Another way by giving, this part will not be there. So they will give you simply reactant and this arrow mark and this reagent they will ask you to write the product. So what is the product in the following equation like that. And third way they can ask you in the form of conversion question. How they can ask you in the conversion question? This alcohol name is 1, 2, 3. Propane to all. How do you convert the following? Propane to all to acetone. Propane to all to acetone. So in conversion also they can ask you. Complete the equation also they can ask you. And they can ask you in that manner also. So please be thorough with this concept. Now we'll go for third one. Third method is ozonolysis of alkane. Ozonolysis of alkene, very important. Ozonolysis of alkene and easy also, very very easy. Just I'll give you the direct method, one normal method also I'll give you and shortcut method also. Ozonolysis of alkene. So here I am taking any alkene, R, CH double bond, CHR, okay, alkene. So if you see in arrow mark this one, ozone, first reagent, second reagent, zinc plus water, very important ma. If you see this reagent, ozone, zinc plus water, see first itself I am giving you direct method, okay, DM, direct method for writing the product. Because in exam they can ask you the direct also, in CBSE also, in competitive anyhow you will not go with the long method, always you will follow direct method only. But in case of board exam, if they are asking you especially write about ozonolysis of alkene, then you have to follow long method. But if they are asking you like this, write the product, then there also you can follow short method. Now even CBSE is splitting the question into 1 mark because of that only, to avoid the lengthiness. So directly you can follow the short method and you can write the product. How we will follow? See, oxygen is having how many oxygen? 3 oxygen. So this zinc carbon single, so give 1 oxygen to zinc. So what it will form? Zinc oxide. Now how many oxygen remain? 2 oxygen remain. So what we will do? Break the double bond between this carbon. Carbon double bond break. Now if you break, you have to make also. So what we will do? Give 1 oxygen to this carbon. Where you are breaking, there only you have to make a bond. So I am breaking this bond. I am splitting molecule. I am breaking the bond. Both the bond I broke. So 1 oxygen to this carbon, another oxygen to this carbon. Now what will be my product? RCHO. See here, actually here double bond you are breaking. So carbon will make double bond with oxygen. You have to remember. We can write like this also, no problem. Same manner. Say RCHO is actually what ma? If I expand this structure, RC double bond to H. Same problem. Nothing difference, okay. Same this part also, see, this part also plus, here this R, I am writing first this R, and here I have CH, and that bond I broke, so I have to make a double bond with oxygen. Carbon should make a double bond with oxygen. Now, RCHO, zinc oxide. So this is you are writing, not a problem. Just it is a direct method. What we are going to do, ma? Break both the double bond, and where you are breaking the double bond, to that carbon give 1 oxygen. That's it. Directly you can write the product. For example, here I am writing CH3, CH3 double bond CH3. Now what is the product? So here the questions in arrow mark I am giving you O3 and zinc plus water. Please pause the video and try to answer. So same. After you got answer, then only you please check. Don't copy first itself. What I am going to do, I am breaking both the double bond. 1 oxygen giving to this carbon, another oxygen giving to this carbon. So what is my product? Here CH3 and here CH3 double bond oxygen plus, here see I am writing from here CH3 I have and CHO. That means ozonolysis of alkene can give you aldehyde, can give you ketone or mixture of aldehyde and ketones depending upon the alkene which you are taking. Depending upon the alkene which you are taking. Now just see the long method, just I will give you, not long method, one step will be extra. I am taking the simple alkene CH3 CH double bond CH2 and first step I am treating with O3. Now what we will do now? We will make a hut type of structure. How? See this bond here we are breaking one oxygen up, two oxygen down. So we are breaking this bond and I am going to do CH3, CH here we have broke the bond, right? CH2, here one oxygen, below two oxygen and oxygen making, like a hut type of structure. So this form is known as ozonoid. This form is known as ozonoid. So first alkene react with ozone to form a ozonoid. Now here in the presence of zinc and water, what will happen? Now we are going to break the bond. See how we are going to split this bond is, see here, this bond, so here CH3CHO, this bond we have broke, and this bond, here CH2. Now this oxygen will be taken by zinc, that's it. So here what we are going to write? Here I am writing down, no space, CH3CHO plus CH2H, shall I write as a H2CHO? Same only na? CH2. Instead of writing 2H2 here, I wrote one hydrogen left side, same meaning, no problem. So H2CHO plus the one oxygen will go with zinc. So this is the product. Actually, if in board they ask you write about ozonolysis of alkene, you have to write this. Otherwise directly you can follow the direct method in order to find the product. Now this is the third method of preparation of aldehyde and ketone. Next we will go for fourth method. We will go for fourth method, that is hydration of alkyne. Important. See, everything is important in CBSE also, everywhere. But from which part frequently asking question, that you have to focus on. All are important, but priority you have to set. For example, in preparation, if I see, most of the time repeated questions coming from oxidation of alcohol. Second, it is coming from hydration. Third, coming from ozonolysis. So while reading, you have to read everything, but read priority, means number of time, repeating time should be more for the more repeating topic. Okay. So now hydration of alkyne. What is the meaning of hydration of alkyne? Is addition. Hydration means addition of water. So we are going to add the water to alkyne. Not only we are adding water, one more steps we are going to do, tautomerism. So here what we are going to do? Addition of water. Addition of water according to Markovnikov rule. According to Markovnikov rule. And second thing what we are going to, followed by, here itself I will write, followed by tautomerism. Followed by tautomerism. Followed by tautomerism. Okay. So if you do like that, then you will get the carbonyl compound, aldehyde or ketones from this. First member of alkyne, that is the CH triple bond CH, which is known as ethine, IUPAC name. What is the common name? Acetylene or acetylene also you can say, acetylene. This will give you aldehyde. All other aldehydes, all other alkyne will give you ketone. Remember, first member of alkyne only give you aldehyde. Remaining alkyne gives ketone. So first thing. So first alkyne give you aldehyde, remaining alkyne will give you ketone. Now let's see how it is. I am taking one example, RC triple bond CH. This is my alkyne. What I am going to do? I am going to add water. How I am going to add water? According to Markovnikov rule. Water contain what? H plus OH minus. Now what is the Markovnikov rule? What is Markovnikov rule? You focus on multiple bonded carbon. Break the one pi bond. Now, addition of negative part, or you can say negative part, goes to that carbon which contain less number of hydrogen. Positive part goes to that carbon which contain more number of hydrogen. So this is what Markovnikov rule. Again repeating, negative part goes to that carbon which contain less number of hydrogen, and positive part to that carbon which contain more number of hydrogen. Now if I not this part, okay, only you have to focus on multiple bonded carbon. Among them which contain less number of hydrogen, to that you give negative part. Other carbon obviously will take positive part. Now if I focus here, in out of this two carbon which contain less, this carbon contain one hydrogen, this carbon contain no hydrogen, 1 and 0, which is less, is 0. So what we'll do, I'll attach this OH to this carbon and H to this carbon. Remember, we have broke this one bond. So what will become? R carbon OH. Now one bond we broke. So how many bonds remain? 2 bonds remain. Then CH. Now we are going to do tautomerism. What is this tautomerism? It is actually 11th class, but you can learn over here also. No problem. Simply, the double bond between these two, I am shifting to here, and this hydrogen I am giving to this. Remember, this is like this. I am having a system X, Y, double bond Z, and X is having hydrogen. X is having hydrogen. Then what I am going to do is, I think this, the double bond between Y and Z, I am shifting between X and Y. And the hydrogen of X I am giving to Z. So like here also you can see over here, like it is a X, it is a Y, it is a Z. So the double bond between Y and Z shift between X and Y, the hydrogen of X given to the Z. So in case of hydration of alkyne, always that OH is there, that you make as a X. Then next carbon will be Y, and after that don't come this side. Double bonded carbon you give as a Z. So when there is a double bond between Y and Z, that shifted between X and Y, and the hydrogen of X shifted to the Z. Or simply by seeing here you can understand, whatever bond, this double bond you shift between carbon and oxygen, the oxygen hydrogen you just give to this one. So what it will become? R carbon. Now we have shifted double bond over here. This double bond have shifted, so become single bond. Then here you have a, what you have? CH and this CH2, sorry. Original CH was there and the H plus attached now. Hydrogen one more. So CH2. Now the CH2 and H, what will become? CH3. So what is this? Ketone. Now some students might be getting confused. Here we are having H plus, here OH minus, but here no charge. See children, don't bother about charge. Why? Because when you are shifting here actually electrons minus plus, and that will neutralizes this plus minus. So just you remember, in short, we are breaking the pi bond, and during hydration HOH is there. The OH we are giving to that carbon which contain less number of hydrogen, and hydrogen giving to that carbon which contain more number of hydrogen. And after that you do tautomerism. What is tautomerism? This double bond between these two carbons shift between carbon and this oxygen. The hydrogen of this oxygen give to this carbon. Or you can remember as this system also, X, Y, double bond Z, and X is having hydrogen. So the double bond between Y and Z, we are shifting between X and Y, then hydrogen of X is given to Z. So, but when you are doing the hydration of alkyne, the which atom you are going to make as a X? Oxygen. Remember, oxygen atom you are going to make a X, then that oxygen attached carbon you are going to make Y, and the double bonded, next to that double bonded carbon you are you are going to make as a Z. So remember like this. Okay. So these are the preparation methods of aldehyde and ketones, common method. So next lecture we'll looking for only aldehydes, only ketones, then we'll move to the physical properties and chemical properties. All the best, study well. Thank you.